And we're back to freecodecamp, still JavaScript. We are right here, Object Oriented Programming. So a couple of concepts are introduced, for example, the this keyword. Let's just dive right in. Right here we'll create a basic JavaScript object. We've done something similar in previous course sections. So we need these curly brackets. And then we can add properties, for example, name for our dog Charlie. If we want to add more, we'll need to separate them with a comma. Be careful, we don't need equal signs. When you create objects, you need to use these double dots. Replace equal signs and then you're good. Let's use the dot notation to access properties in our object. So for example, here we've got the object duck, and duck.name would access the value flag, which belongs to the property name of the object duck. So in our example on the right hand side, console.log, our object is called dog, and then we'll access the property, for example, the name. So we'll get spot, and .numlex would give us the number 4. We want to create a method on an object. In the example on the left, we've got sayName, which is a function inside of an object, and then it's called a method. So technically it's a property that is a function. So for example here we've got sayName, and it would return the name of this duck is duck.name, so a flag. Therefore if we print that out, we would get this string plus the name flag. Let's go over this on the right hand side. At first we'll add sayLegs right here as a property. We'll use the keyword function and return. And then we'll add our string. This dog has 4 legs. This would already work. But if we want to, for example, use the property numlex, let me show you this as well. You use the plus sign and then you access the dog object .numlex. Again, plus sign for the legs, and don't forget the white space after and before our numleg, which would be 4. Next one is make code more reusable with the this keyword. So this might be new. I don't think that we've used it so far in freecodecamp. And here we have it introduced on the duck object. Instead of duck.name, it's this.name. Usually you want to replace that. In case, let's just say you want to rename your object for some reason. You would also have to rename all of these dot notations. If you use the name instead of this, am I using this? You can get around it. Let's move on to define a constructor function. So you could see this as a basic object. Here we've got a function called bird. So this is our constructor for bird. And we could now create individual birds using this. It becomes clearer when we proceed. Let us first create a constructor of our own. So we need the function keyword. We'll make it dog. And we want to have properties name, color, and numlex. So we'll have to use this name. Then comes an equal sign. So it's different from these regular objects, and we'll separate it with a semicolon, not a comma. Careful here. I'll just invent some values like Charlie Brown, and for numlex I'll make it 4. And now we'll use a constructor to create an object. So once again, here's our bird constructor, and then we can use it to create an object called bluebird. So it simply uses this constructor, and then all of these values for name, color, and legs will be part of our new object bluebird. So if we, for example, try to use dot notation bluebird.name, our bluebird would have the name Albert thanks to the constructor bird. Let's do the same on the right hand side. We'll create an object called hound. We'll use the keyword new and then use our constructor dog. Therefore, hound.name would be Rupert, and so forth. Our constructors can also receive arguments. If you want to, for example, create a swan, it would get all of the values the bird constructor has, but you can also, like with regular functions, add name and color to our bird as parameters. When we now call it, you could say with swan, we can add specific values to it, and that would replace the regular name for the bird. So let's do this right here. We need our dog constructor, this .name equals name, and this color equals color. This numlex equals 4, because dogs always have 4 legs. So there is no reason to make it a variable. We can just give it a fixed value of 4. Now we create a new object called terrier. And this time we want to pass 2 arguments. Should be strings for name and color. So we'll have to add them here. These are our parameters for our dog function. And now we'll pass values. Let's once again call them Charlie. And for color, we'll add, let's say, black. So now our terrier.name would be Charlie and terrier.color would be black. Verify an object's constructor with instanceof. So we can check if an object was constructed by a given constructor function that we've created. In this example, it's the bird constructor. We've used it to create the crow object. We've passed 2 arguments, Alex and black, and this makes crow an instance of bird. So if we check it, it would return true. But if we create, for example, the canary object without using bird as a constructor, instanceof would be in this case false. That's just a simple way to check if we've used this constructor to create a certain object. We've got a house constructor. We'll create a new object called myHouse. Don't forget the new keyword. We want to pass an argument for num bedrooms. I'll make it 2. And if we check now my house instance of house, this would be true. So just like with the crow. So let me just print it out so that you can see it. So console.log, and I'll paste it here. And we've got, well, let me get rid of the semicolon, and we've got true right here. We'll move on to understand own properties. The constructor bird has two properties, name and numlex. So if we create a duck and a canary using the bird constructor, they will have these properties as well. And now we can check using hasOwnProperty if a certain object has that. So the duck, for example, would have two own props, so the ones that were given to it by the constructor bird, so name and numlex. We'll just use a simple for loop and then an if statement to check. But it's a for in loop, I'm sorry, so not a regular for loop, it's a for in. Let's repeat it here on the right hand side for our bird constructor and the canary object. So it's a for let property in canary, so in our object. Therefore we'll cycle through the property that it has. And for each we want to check if the canary dot has own property. And in a parenthesis we need a property, so for every property we'll check if it's part of the duck. And if it is, we're going to push it to our array own props that's declared right here in code line 7. And if it's not going to get pushed, so it's not part of our own props array. Let me just print it out so that you can see that ownProps now has the name and the numlex, so the two properties from our bird constructor. And it's an array. So we've declared that by using the square brackets. Now we want to use prototype properties to reduce duplicate code. So this is something new. Read through it carefully. Maybe you want to pause the video and check it. Try it out yourself, and if you get stuck, then use my solution right here. Or we can, for example, define the numlex as a prototype for the bird constructor. So let us do this on the right hand side for our dog constructor, dog.prototype .numlex equals 4. So the beagle would get it as well. As previously mentioned, dogs always have 4 legs, so we can easily do that. And if we now access it by using the dot notation beagle.numlex, it would be a 4. So now we can check if an object has an own property or if this property is a prototype property of the constructor. So this brings together the last 2 or 3 tasks, 2 or 3 exercises here. We've got our bird constructor again. This.name is a property that the duck is going to have itself, but the prototype numlex will only be part of the constructor. So if we iterate through our properties in duck, we now have an if and then also an else statement, because the prototypes will not be pushed as it's not an own property of duck. It becomes clearer if we go over this on the right hand side for a dog constructor. We use a for in loop, so let property in our beagle object. And we want to check with an if statement if the beagle has own property. I will check for each property in our for loop. If so, we'll push that property to our own props array. And if not, we'll end up with the else statement right here. And we can push the property to our prototype props. So in our case, this.name will be an own prop of the beagle, but the dog.prototype.numlegs in line 5, it would be a prototype props. So you can see that right here if I print it out. Own props is name, prototype props is numlegs. Understand the constructor property. Alright, we've got a special constructor here for duck and beagle that we've created with our constructors bird and dog. So we can check that with a strictly equal sign. And it would return true in both cases. And we want to do the same and check on the right hand side. So we're going to use the join dog fraternity candidate as our parameter here. So for a specific candidate, we want to check if the dog constructor is strictly equal to dog. I want to return true. And in the else case, we'll return false. So that was a simple exercise. Let's go to change the prototype to a new object. And here's simply a more efficient way introduced. So we don't have to add prototypes one by one. We can just create basically like a collector for all of these prototypes. And there's going to be a new object. So here we've got the dog.prototype object. And we can add our numlegs once more. And we'll add a method called eat. And also a method called describe. Be careful, don't forget this comma right here in code line 10. So that way we're going to separate eat and describe. And we could give this like a console.log, but we can just leave it open, I guess. Yes, we can just leave it open in this task. So we're ready to proceed. Remember to set the constructor property when changing the prototype. So we've got an example on the left hand side. The duck constructor bird would be false. The duck constructor object would be true. And duck instance of bird would be true again. So it kind of overrides. So you could say overrides and erases the constructor property. We'll add that by using a specific property called constructor inside of our prototype object. So dog.prototype will be the same right here. For bird.prototype, we'll just add constructor and then the name of our prototype object here. And then we've got it fixed. So whenever it overrides, it's still there as a constructor. Next up is understand where an object's prototype comes from. So an object inherits prototypes from the constructor. In our case here, the duck is the object. It inherits the prototype from the bird constructor. And on the right hand side, the beagle would inherit it from the dog constructor. So let's check this. Dog.prototype.isPrototype of beagle, and this should be true. So if I print it out using console log, there you go, it's true. So it's because we've created our beagle object using the dog constructor, and this makes it inherit the prototype. And you could call this a prototype chain. So all objects have a prototype. Also an object's prototype itself is an object. So here we check our object.prototype is prototype of bird.prototype. This would be true. So just like we did before, our beagle was a prototype of the dog. So just like before with the dog.prototype is prototype of beagle, this was also true. And the object is, you could say, it's one tier above our dog prototype. And on the left hand side it's the same for the bird prototype. The object is one tier above it, and the duck would be one tier below it. And let us check what we need here. I'll use console.log to print it out, and we'll simply use the object.prototype and .isPrototype of dog.prototype. This should be true then. So the object itself is just false, but if we add the prototype, it's true. And it's simply this chain. You could also call it a hierarchy, whatever word you want to use here. And there you go, it's true. Let me get rid of console.log, we don't need it here. We should pass the test. We'll proceed to use inheritance so you don't repeat yourself. So we can make code simpler whenever there's a chance to get rid of repetition. It's a good idea to do that. Here we've got the bird and the dog prototype, and they have the same describe method. So we can group that together and create an animal.prototype. And then we can get rid of our describe method in the bird and the dog as long as bird and dog use this animal prototype. Let us do it on the right hand side. We've got, for cat and bear, we've got the eat method. And we can group that and then get rid of it. So again, we use an animal.prototype, constructor animal. And if we copy paste our eat function, our eat method inside of it, should be good. but let me check. I believe I've gotten one of these brackets too many. So I'll press Ctrl Z. Before I make a typo here, we need this one, 18 to 20, and then I paste it. So the bear is fine, the animal is fine, and now we can delete it right here for the cat, and we should be good. So the less code you write, the less typos you can make, or the less mistakes you can make in general. So it's always a good idea to do that so that you can get rid of repetition. Next up, inherit behaviors from a supertype. So we've created a supertype animal for, what was it, our bird, and I believe the dog. And here we'll use a similar principle. Once again, it's a good idea to read it yourself, pause the video. If this is totally new to you, try to understand it and solve it yourself, and then come back. So for example here, our animal.eat would work, as eat is a part of our animal supertype, and therefore animal instance of animal, so with a capital A, would be true, as we have used let animal equals new animal. So we have created this animal object using the supertype animal. On the right hand side, we'll create our drag object using object.create animal.prototype right here. And now we can do the same to our beagle, and this should solve the exercise. Set the child's prototype to an instance of the parent. So again, it plays around with inheritance and this hierarchy of objects, prototypes, supertypes, stuff like this. What we need to solve this exercise on the right hand side, we've got our let beagle equals new dog, and we want to make it so our dog inherits from animal. We use the dog function in code line 10, and below it we'll have to add this one. So we use the dog.prototype equals object.create, and then we'll use the animal.prototype. So it's the same code line that was used here for the bird on the left hand side. And this time we want to do it to the dog. And now we'll use let beagle equals new dog. Therefore, beagle is now an object. I can use the eat from the animal prototype because it's connected via dog, so this constructor, and we should be good here. But we actually don't need the beagle.eat, so let me delete it, but you've seen that it would work. Alright, let's move on to reset an inherited constructor property. Okay, again, an object, when it uses the property from another object, it also inherits the supertype constructor property. Yet again, it's this chain where they're all connected depending on the hierarchy. Here we've got our bird prototype. It uses the animal prototype So animal is one tier above bird, and duck is below it. And we'll do the same on the right hand side. We've got animal, dog, and bird. And we've got object, duck, and beagle. So we need to do it for both. Let us go over the duck first. We can simply copy paste this code line. So we'll use the bird prototype. Afterwards we'll use the dog prototype, constructor, and set it equal to dog. And then we should already be fine. Next up, add methods after inheritance. Again, a longer text, so pause the video, read it yourself. You don't need me to read it to you. And then come back if you get stuck. So here we've got the animal. You could see as on top of the bird. But we want to add stuff to the bird that's unique. For example, only birds fly, but pigs don't. But both are animals. So how can we do that? Let's check the right hand side. For an example, animal, dog, beagle. So all animals, for example, they eat, but not all animals would bark. This is something only dogs do. So let us check this code line. Here bird.prototype equals object.create animal.prototype, and we'll need to set this to dog. So we've got that covered, but specifically afterwards we want to add properties to our dog. Let us also add the dog.prototype.constructor equals dog. And now we'll add our bark method, and we need to add it to the dog. Dog prototype, but not fly, we'll need bark. And it should print out woof. And now the beagle, which is constructed via a new dog, will have the bark method and also the eat method. So the bark method comes from the dog, and the eat method, it comes from the animal. So if I print, for example, bark out, we've got woof now. You can see this function is available. Let's go to override inherited methods. So the child object up until now was always the bird, parent was always the animal. Now we can override stuff. Let's do that here. On the left hand side, animal has the eat method and returns num num num. And we can override this for the bird. So simply use the same prototype.eat. So it's the same syntax that's used for the same method, but a different return is being added. So it's pack in this case, and it's going to override it. On the right hand side, we've got the fly method right here. I am flying for our bird. But penguins, they are birds, but they can't fly. So we want to override this fly method specifically for penguins. Therefore, we've got to use this code line bird.prototype.fly equals is to return, and this would give our penguin. Well, obviously we want to add it to the penguin and not the bird, so my mistake here in code line 10, obviously we need to start with penguin.prototype.fly and not the bird. The other birds, they can fly. So this needs to be fixed. And now we should be good. Use a Mixin to add common behavior between unrelated objects. So far we've always used animals, but an airplane, obviously not an animal, but airplanes and birds, they can both fly. There's a way to connect these two, even though they're not part, or even though they're not both part of the same parent. And it's shown here by using a fly Mixin. So in the example, the object is basically used as a parameter, and then we can use fly for both of these objects. The way to solve this exercise on the right hand side would be let glide Mixin. So it's a Mixin that will give the glide method to bird and boat. So we need the obj parameter .glide, and then we'll define that method as, let me check, we need console.log, or we can just leave it like this, so there is no real content given. But by writing it like this, boat and bird can now use it. And then we use glide Mixin for bird and boat. And we're good here. Next up, use closure to protect properties within an object from being modified externally. So you can make public properties private, and that way they can't be modified externally anymore. So we want to perform what is called a closure, which you can see on the left hand side as the bird example again, and then ducky is the object. We want to perform the same on the right hand side for bird. At first, we'll need to get rid of this weight equals 15. Instead, we'll declare the variable weight right here and initialize it to 15. Then we'll create this method getWeight. What shall we return? Let me check. We need to return the weight, and afterwards we should be basically good here. Let me check. And it should already be it. We have now turned weight into a private variable. So I can just run it and we should be good with our closure here. Now a new concept is introduced. Again, read through it slowly, carefully. It's called IIFE, immediately invoked function expression. At first we'll go over the simple syntax of it and we'll recreate it for our make nest on the right hand side. So we can, for example, copy paste this. And we'll just change right here the string that we use in console.log. So this exercise is only an introduction to the syntax. And now we're using it to create a module. And I believe this is the final task in object-oriented programming course section. So here you can see these IIFEs in action. And they're going to group two mixins for glide and fly. So by using that once again, you can group stuff, make it more simplified, and therefore reduce the potential for making mistakes and simple typos. Let us recreate it on the right hand side. We've got our queued and the sing mixin. And we can group it by using this IIFE. We'll call the module fun module. So we'll use let fun module. I will add the syntax for our IIFE. But you know what, let me just copy paste this before I make any typos. So now we have to change it for our queued and sing mixin. So the glide mixin right here needs to be replaced with our queued mixin. It takes the object as a parameter, that's fine. But object glide must be obj.isQueued. And the function needs to return just true instead of this console.log. So let me replace this, return true. Now we'll go over the second part, which is the sing mixin. This should replace the fly mixin. It still uses the obj as a parameter for the function. It's fine. obj.sing should be correct. And then we'll need this string right here, singing to an awesome tune. And I can delete code line 5 to 1. And now this should be grouped. Let me check. And that was correct. And indeed, we are done with object-oriented programming, at least here in freecodecamp. Couple of new concepts. It's always best to read through this yourself slowly. Try it out yourself, and if you get stuck, then refer to my walkthrough. I'll try to finish functional programming, which is next, until next week as always. I hope this video was helpful. Thank you for watching, and I'll see you next time.